The earlier class we have worked out the theory of trapezoidal rule and also make the corresponding program for a fixed time. Today we shall discuss Simpson 1/3 rule. Before going to the Simpson 1/3 rule, let me first remind you what we have done in the earlier in trapezoidal rule. In trapezoidal rule, when applied to a block formula, that is, if we like xi and another point xj, then we approximated the curve between these two by a straight line. It is a straight line curve or linear curve, and we use the formula y is equal to alpha x plus beta. And if we integrate y dx, then we get half alpha x square plus beta x. So to know the integration, use the integration, two conditions are needed. We use the two conditions as the two consecutive values, so that this becomes x I to I plus 1, that is, this was equal to I plus 1. This is trapezoidal rule. In Simpson 1/3 rule, we approximate the function within a block by a quadratic equation expression, that is, the formula is a parabola. The graph is a parabolic curve. That is to say, if we have xi over here and xj over here, between xi and xj, we approximate the curve like this. This is the original curve, and we approximate the curve by a parabola. So this is a parabolic curve. This is Simpson 1/3 rule. Simpson's 1/3 rule. This is parabola, parabolic curve. So the equation is, for a parabola, alpha x square plus beta x plus gamma. So whenever we integrate y dx, we get 1/3 alpha x cube plus half beta x square plus gamma x. This is the form. So if we want to get this the value for the corresponding definite integral, we need to know alpha, beta, gamma. So this can be known from this. yi is equal to alpha xi square plus beta xi plus gamma. yi plus 1 is equal to alpha xi plus 1 plus beta xi plus 1 plus gamma, and yi plus 2 is equal to alpha xi plus 2 whole square plus beta xi plus 2 plus gamma. So these three equations, in which yi plus 1, yi plus 2, xi plus 1 and xi plus 2, these six quantities are known, which enables us to determine alpha, beta, gamma. So three conditions are required. That is why we write it as xi and xi plus 2. So there are three conditions. So this is xi plus 2. So for this case, it is I plus 2. Note the difference that I am going to indicate in reading. For trapezoidal rule, j is equal to I plus 1. For Simpson 1/3 rule, j is equal to I plus 2. So if we want to divide the entire interval into blocks, integral number of blocks, the number of integral must be even, because each block comprises of two intervals. there is an interval I plus 1 in between. So if we divide the entire interval such that b minus a is equal to this, n must be even. A restriction must be satisfied in Simpson 1/3 rule. There were no such no such restriction in trapezoidal rule. There is another rule called Simpson 3/8 rule, in which case it is cubic integrating polynomial, that is the graph within a block is approximated by a cubic polynomial, that is in which case it is alpha x cube beta x square gamma x plus delta. Since four quantities are to be measured in this case, we use the result as yi plus 1, yi plus 2 and yi plus 3. Here a block comprises of 3 intervals. So if you want Simpson 3/8 rule, then the n should be 3 times m, where m is an integer. Here n is equal to 2m, even here. So a restriction comes in this way. Now I want to find out the block formula for Simpson 1/3 rule. First I shall find out the block formula and then we go for the composite formula, which is a trivial one. So the block formula for Simpson 1/3 rule. We integrate y of x from xi to xi plus 2. The reason has been explained. So this is integration alpha x square plus beta x plus gamma dx integrated from I to I plus 2. This is alpha by 3 xi plus 2 whole cube minus xi cube plus beta by 2 xi plus 2 whole square minus xi square plus gamma xi plus 2 minus xi. We write this as alpha by 3. For this part we write xi plus 2 minus xi times xi plus 2 whole square plus xi plus 2 xi plus xi square. We have used the formula of a cube minus b cube plus beta by 2 xi plus 2 minus xi into xi plus 2 plus xi plus gamma xi plus 2 minus xi. You note that this is equal to 2h. There are such terms in all the 3 terms. So we take 2h common. So this is taken 2h common. This is alpha by 3. Then this part, this xi plus 1 is actually xi plus h, and xi plus 2 is equal to xi plus 2h. So from this term we get a xi square. Here is an xi square, here is an xi square, 3 xi square. Then xi plus h, here we have when we square it, it is 4 xih and there is 2 xih, so 6 xih. And coming to h square term, here we have a term 4h square. Actually this term, remember that xi plus 2 whole square is equal to xi plus 2h whole square, which is xi square plus 4xi into h plus 4h square. This is then this is xi plus the and this is simply gamma. Now to know this term, the right hand side in terms of yi plus 1 and yi plus 2, one need to solve the three simultaneous equation, which is not very easy always. So we do one thing, keep some space, we try to evaluate this quantity. Now if we write this is alpha xi square beta xi plus gamma, this is the first term, plus 4 alpha xi plus 1 whole square beta xi plus 1 plus gamma plus now let me collect the coefficient of alpha first. This is the coefficient of alpha. Now coming to the coefficient of beta. This is 4 beta already there. Then xi plus 4 into xi plus h plus xi plus 2h. This is for xi plus 2, and the gamma part is gamma plus 4 gamma plus gamma, so 6 gamma. Now let me write this one. Alpha, then alpha square plus xi square, 6xi square. Then you will have 8xih, and here we will have 4xih, so 12xih. And coming to h square, this is 4h square, then again 4h square, so 8h square. This is all about alpha coefficient. Oh, I have this should not be there, it's wrong. Beta. So beta is xi, beta xi plus 4 beta xi plus 1, and so this beta part is xi plus xi 4 5 plus 1 6 beta times 6xi, and coming to h part 4h plus 2h 6h, and this is 6 gamma. If you take 6 common, then we will have 1 6 This is alpha y3. 6 is adjusted, 2 is taken common from this, and so this is 3xi square 6xih plus 4h square this quantity within the third bracket is exactly equal to this, so we can write it as this divided by 6. So this is 1 by 6 into this is 2h were there, then this part is replaced by yi 4yi plus 1 plus yi plus 2. Now on cancellation, this is h by 3 yi plus 4 yi plus 1 plus yi plus 2. This is the block formula. So the final result can be written as final result for Simpson 1/3 rule can be written as h by 3 yi 4 yi plus 1 plus yi plus 2 as the block formula. Now coming to the composite formula. The composite formula, we divide the integration we write the integration x0 to xn. N must be even. x0 to x2 y dx plus y dx x2 to x4 plus now if we write the each term explicitly, we get h by 3 is common, so we take h by 3 common from all these three terms, all these terms. Then from this is y0 plus 4y1 plus y2. This is for this block. For the next block, it starts with y2, so this is y2 plus 4 y3 plus y4. This is for this one. And if we write the next one, this would be y4 plus 4 y5 plus y6, and going in this way. For this one, it will be yn minus 4 plus 4 yn minus 1 plus yn minus 2, and for the last one, yn minus 2 4 yn minus 1 plus yn. This is the, if we now collect all the terms, you see that y0 and yn comes only once. y0 and yn, there are no other occurrence of y0, either of y0 or of yn, so this is y0 yn. Then the odd term 4y1 4y3 4y5 and so on and so forth. So 4 times y1 y3 and ultimately ending up with yn minus 1 plus there is a y2 and this y2 couples to get 2, this gets 2, and similarly you see that this makes it 2. So this is 2 times y2 y4 y6 up to yn minus 2. So this is the composite formula. This is the composite Simpson formula. Now we are to make a program for this. So before going to the program, let me write the formula for Simpson 1/3 rule, and remember that n must be even for Simpson 1/3 rule. Oh, this 1/3 is the reason for writing it as this. This is f, y0 is actually f of a, yn is f of b plus 4 times the odd terms y1, y3 ending up at yn minus 1, and 2 weightages given to the even terms starting with 2, 4 and ending at n minus 2. This is the formula. Now coming to the Fortran program. Again, this is a simple-minded program. This program will take single value of n and calculate the integral. So for the accuracy or convergence of the result is concerned, n has to be changed. So for Fortran program, again, read star comma star a b n. We define h. First check for n. M is equal to mod n. This gives you the remainder when n is divided by 2. If m is 1, then the number n is odd. So if m not equal to 0, here not 0.0, then n must be even. Stop. So what this part does, if we supply n value as something which is not an even one, the program stops there. Before stopping, it gives the message that n is not even. Then we define h. H is defined as h is equal to b minus a by float n. Float n. Then coming to this part, we write sum even as sum odd is equal to 0.0. Then do blank 1 blank I is equal to 1 comma n minus 1 in steps of 2. So first value will be taken 1, then 3, then 5 till so xi is equal to a plus float I star h. H is defined earlier. Then sum odd of f of xi, where function has to be defined, as we have done in the case of trapezoid. So continue. Now the odd sum has been carried out. Now coming to sum even. Do blank to blank I is equal to 2 to n comma in steps of 2. Again xi is equal to a plus float I star h, float I star h, sum even is equal to sum even plus f of xi to continue. Then after this line we come here. R, I and T is equal to, first we take these two terms, f of A plus f of B plus 4 times odd 4.0 star sum odd plus 2 times 0 star sum even. Entire thing is multiplied by h divided by 3.0. So the program, then write A, B, N, R, I, N, T, stop end. Now coming to the subfunction. Function blank f of x, f is equal to, as for in the earlier case, which I this completes the Fortran program using Simpson 1/3 rule. Again, there is a limitation of the program. The limitation is that this program calculates the value of integral for a given value of n and takes no care about the convergence of the result. So, as I have stated or elaborated in the earlier class, that the convergence the measure of or care of convergence may be taken care of either by increasing n till the desired level of accuracy is achieved. Otherwise, the program may be done in a more sophisticated way, in which case the program itself would take care of the convergences. I will come to this program in a next class. For now, it's a simple program using Simpson 1/3 rule.